Hi class, this is Professor Smith. I'll be doing a movie on rational zeros theorem, taking a look at when we have irrational zeros. It tells us in this example that the function has at least one rational zero, and we're going to use this fact to find all the zeros of the problem. So we're going to let p equal the constant term, -5, and q equal the coefficient of the leading term, which is 7. So we know that our roots are going to have all possible multiples of 5 over the all possible multiples of 7. So we know that x could be all factors of 5, which are 1 and 5 in the numerator, and 7, which are 1 and 7. And so our possible roots would be 1 over 7, 1 over 1, and 1 over 7, and then 5 over 1 and 5 over 7. We can simplify the 1 over 1, and it's 1, and then the 1/7 will still stay the same, and then 5 over 1 will be 5 and 5/7. And recall from the previous videos, of course, that's not including the negatives of all those possible values. So it would be plus or minus 1, plus or minus 1/7, plus or minus 5, and plus or minus 5/7. So let's go ahead and see if 1 or minus 1 are possible factors of our polynomial. So I have 7, -2, -12, -5. -12, negative. So we take a look at the 5. I don't know why I have an aversion to fractions. I should just pick those fractions. All right, let's go ahead and do that. Bummer. All right, so let's try 1/7. All right, so the next thing we're going to try is 5/7. So we are so happy about you, darling. We love you. It was negative, right? So the negative one is a winner, 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 winner. So, to write this down accurately, I should have had x equal to plus or minus 1, plus or minus 1/7, plus or minus 5, plus or minus 5/7, and the winner was -5/7. All right, so now that we have that one root, we can use the synthetic division to find. Oh, they just want us to write the values. I didn't need to do all that. Maybe I'm over my limit. Five. All right, so we're going to try 5. And again, our 5. Bringing down the 7, this does not look good. 35. No, we're going to let that go. Let's try -35. I think that's bad too. All right. No, that just goes from bad to worse. All right, so 5 is out. So I'm going to use 1, and then I'm going to grab the coefficient. Oh. So 7, -2, So I'll bring down that 7. 1 times 7 is 7. When I add, I get 5. 1 times 5 is 5. When I add, I get negative 7. And unfortunately, that's not going to give me a remainder of 0. So let's try negative 1. Bringing down that 7. I have negative 7, which will give me negative 9, which gives me 9. And again, I don't think that's going to work. Leading coefficients were 7, negative 2, negative 12. Excuse me, it's 7, negative 2, negative 12, negative 5. So it's 1. So 1/7 of 7 is the same as taking 7 and dividing by 7, which is 1. We add those, we get negative 1/7. And then we take negative 1/7 times 1/7. It's negative 1 over 49. So I don't think that's going to work. All right, let's try negative 1/7. 7, negative 2, negative 5. 7, negative 2, negative 12, negative 12, and 5. I don't know how to do that. I'm accidentally creating an extra page, and I don't know how to delete an oops. Oh, well. So we have 7, negative 2, negative 12, negative 5. We'll bring down that 7, and 5/7 times 7, they cancel, and that leaves us with 5. Negative 2 and 5 is 3, and 5/7 times 3 is 15/7. And negative 12/7, negative 12 over 1 plus 15/7. So we're going to multiply the negative 12 over 1 times 7 over 7. So that gives us negative 84/7 plus 15/7. And negative 84 plus 15 is going to give us negative 69/7. And that's not going to definitely give us a positive 5. All right, so let's try 5/7. Negative 2, negative 5/7. So we had 7, negative 12, and negative 5. Uh-oh, is it creating a new... Oh, new time starts on each page. That's interesting. I'm just looking at the timer on the recorder. All right, minus 5/7 times 7. The 7 cancels, and that leaving with negative 5. Hot dog! Negative 5/7 times negative 7. So that cancels the 7 in the denominator with the negative 7 and gives me negative 1. So I get a positive 5. Shut up! Negative 7. Negative 5/7 times negative 7 is going to give me a positive 5. Gives me a remainder of 0. We're so happy. So don't try the fractions. I mean the whole numbers. Start off with the fractions. Anyway, so we get x equal to 5/7. Winner, winner, chicken dinner. A problem 2. So we're going to take the coefficients 7, negative 7, and negative 7. Remember, the original polynomial had an x cubed. So we have 1 less than x cubed. The degree would be x squared. So our resulting quotient is going to be 7x squared minus 7x minus 7. So that's our, oh my goodness, are you serious? Those little sneaks. So we want to find out the other zeros. And so what I'm going to do is I'm going to divide both sides by 7 just to make it a little bit simpler. So I'll have x squared minus x minus 1 equal to 0. This one, it does not factor. If you take a look at negative 1, the only factors of negative 1 are 1 and negative 1, and there's no way that that's going to ever add up to negative 1. So it doesn't factor. We also know that because this one says irrational zeros, so the numbers that we're going to get for this quadratic are not going to be rational. They're going to be irrational, so therefore it won't factor over the integers. So we're going to have to use the quadratic formula. So we're going to factor x squared minus x minus 1 equal to 0. Pardon me, we're going to solve x squared minus x minus 1 equal to 0 by using the quadratic formula. So we need to determine what a, b, and c are. A is the leading coefficient of the x squared, is the coefficient of the x squared term, which is also the leading coefficient. So that's going to give us a 1. B is going to be negative 1. And c is also negative 1. And our quadratic formula is equal to the opposite of b plus or minus the square root of b squared minus 4ac. So now we're going to substitute in those values for a, b, and c. So it's going to be the opposite of negative 1 plus or minus the square root, negative 1 squared minus 4 times 1 times negative 1, all over 2 times 1. So we get 1 plus or minus the square root. Negative 1 squared is 1. Minus 4 minus 1 is plus 4, all over 2. I guess I got a little excited on that square root symbol. Don't think I need that much. All right, perfect. And so that's going to give us 1 plus or minus the square root of 5 over 2. So those are our two rational roots. Let's write them out longhand. So now that I've found the values, I'm going to rewrite them instead of using the plus or minus symbol. So I have x equal to 1 plus root 5 over 2, and then x equal to 1 minus root 5 over 2. And then I had our original root, which was, or it's not our original root, but the one that we used, the rational zeros theorem of negative 5/7. So those are going to be our answers. X equal to minus 5/7, comma, 1 plus root 5 over 2, and 1 minus root 5 over 2. So you can tell when you're tired. Little things are a chore for you. So again, a negative 1/7 will give us a negative 1, which will give us a negative 3. And negative 1/7 times 3 negative 3 will give us a positive 3/7. And I just don't see how you're going to cut that's going to end up being a positive 5 when you carry this down. It's going from bad to worse. All right. Take a look at what the resulting quotient would be.